I think we can start. This session will be in English. Hopefully that's okay for all of you. So my name is Maciej Dydejczyk. This is Jakub Świercz, who will be presenting you data platform engineering. So let's just start. Here's a quick agenda, what we will be talking about. So we'll be talking about ourselves in the first place. Then we'll try to explain what the platform engineering is in a nutshell. And in the very end, we'll talk about the ODP spaces. So ODP is one data platform, which is developed for Lufthansa colleagues. We are actually building that. So hopefully we'll give you some insights how such a platform is being built. So let's start. About us. So Kuba.
Hi, so I've been in IT for over 14 years. I started from the data warehousing world, first on Teradata, then on Oracle, and then I moved into Azure, and it's become my love ever since. And now I'm with NoCloud, and we're together with Maciej working for Lufthansa in the One Data Platform project.
Yeah. So my name is Maciej Dydejczyk. I'm as well, can you hear me? Data solution architect. I'm building basically data platforms since like 8 years and started with Hadoop and all those other technologies that came along. Right now I'm just specializing in Azure, doing cloud for like 10 years and being born and raised here in Wrocław. I just work for most of our corporations here and been studying a couple of bus stops from here on University of Technology. Let's go further. So we are working for NoCloud. We have a style here, so you can go and visit us, and there's Asha and our colleagues that will tell you more about us, what we are doing. We are mostly doing cloud. So just come and let's have a chat.
We do awesome things, really.
Okay, so we'll start with the platform engineering, and here I will start with just a short of a narrative what a platform engineering and a platform are. So probably you all know the medallion architecture or the reference architecture of the medallion. So anybody work with this? Okay, so that's basically it, right? We have our data lake, our engine, which might be a Databricks, something that will do orchestration, so ADF, data governance based on pure view, and some security monitoring. And usually in the companies, that's operated by a central team, right? So you have your central team that becomes a bottleneck. And usually, even if you build it, right now, companies want to be more data-driven. You want to democratize access to the data, so we would like to scale that. And here comes the challenge, how to do that. So let's just answer a couple of the questions. So probably you saw on the previous sessions that there comes some added complexity. So the platform does not live on its own. You have the networking. Networking is really complex. You have the DNS resolutions. You have various other components that in a, for example, enterprise world, you need to comply with. And we would like to deal with those complexities and abstract them from the users. That's one of the topics. The other topic is the reliability and resilience, how to manage that. So for example, look at that. That's a sort of the components that we are managing. You have 160 data factories. If you would like to upgrade them, you cannot do that using the ClickOps, right? It's almost impossible. You will do that for the next couple of years. And this screams for some kind of automation, some kind of system, a platform that will manage you to do that and manage at that scale. So there's this provisioning at the scale. Right now we have like, how many? 75 tenants. So those are business units that are having similar platforms, so medallion architecture for themselves, which is provisioned by our automation. Of course, security, regulatory, so CISO and stuff like GDPR and all those things that are given and that you need to comply. It's really important to protect your data so it's not exfiltrated, so it's not used by the corporation. And right now the other corporations, and right now the security is almost paramount thing in the data platform engineering, and it's something that you cannot negotiate. Last but not least, cost effective, right? So cloud is cheap when it's cheap, but usually it's the hundreds of thousands of millions of dollars. So how do we deal with that? So basically, here's the platform engineering that comes to the rescue. So what we want to do is just design, build, and operate a set of tools and services that will enable us to provision such platforms for the end customers. And the end customers might be the business units or might be other development teams who will tackle into this platform and use our services to devise some other platforms or other services. And how do we do that? We use the standard components like DevOps, right? A culture of DevOps, infrastructure. We add to it operations, so it needs to be stable. You need to add like incident change management, maybe all those IT processes. You need to build in security, so it's really important, right? And all of that needs to be managed by some kind of automation because, as we already said, you cannot do that using the ClickOps, right? So what is the platform? And this is picture rewritten by the Kuba or redrawn from Gartner, which pretty decently explains what the platform is. It's basically a set of capabilities that you negotiate with your customer. So platform, that as we know it, and there's no strict definition of the platform, is an opinionated way of doing some or providing some kind of capabilities. And those capabilities might be like data ingestion, might be data transformation. So this is what we call the capabilities. Might be different, but what we are using the infrastructure. We are abstracting the complexity, and we are providing those services. Then you can then see on the top that are either fed to the business or to other different teams that build on the platform. And here are some attributes of a successful platform. So as you can see, it's not always infrastructure and technical stuff. So platform should be thought as a product, and it should fulfill the needs of the customer. So what we are building in Lufthansa, for example, is opinionated infrastructure, processes, and way of doing that fits into the Lufthansa way of working. It might not work for other customers. It's just for our business teams that we are actually trying to help automate and democratize this access to the infrastructure. And as you will see, with platform, you have not only infrastructure, you have like project templates, so quick start guides. For example, in a Databricks world, when we provision a space, so your tenant, we as well are hooking up all the Git repos with all the notebooks that already have the predefined security to all the components, for example, your data. And here you can already start tinkering with data almost in no time. In like 5 minutes, you have your connectors to, for example, Skyscanner data, and you can see how the flights were around the world, and it's working out of the box. So we are building automation to enable the teams to have all the head start and just to abstract the complexity. So those additional things like user experience that I just told you about, documentation is a paramount. It's like basically building a product, so all your software development practices you would like to put into the platform. It's not DevOps on steroids. It's not only terraforming or something like that, but it's something more that you need to tackle into. And basically, why do you do that? To remove this cognitive load. So people who want to do data engineering, they don't want to play with the networking, with private endpoints, with some other things, DNS resolution, that is a bit too complex. We are developing the the platform in such a way that was already said is like building blocks. So you have small components that are building into next services, which are building into next capabilities, and they are reusable, and those as well allows us to basically update each and every component separately without a need of doing ClickOps or some kind of a manual endeavor. And as I said, it's secured by default. So that was the primer. We'll just jump into the ODP spaces, so how we build basically such a platform, and we will go into more technical details, which probably will be the core of the, or is the core of the presentation, and it will be really interesting for you. And handing over to Kuba.
Thank you. This is one data platform. So this was a digital platform which was built in Lufthansa as part of a much bigger digital hub, and we'll show you later how one data platform lives in this whole context, in this whole ecosystem of other corporate IT infrastructure and other platforms. But generally, why was it built? What it has to do? What's its core purpose? It's a platform intended to centralize Lufthansa data into one platform to accelerate and enable data analytics. So to have the data analytics, data scientists, modelers, auditors, marketing teams, simply have a very easy and well-oiled way of working with very various data sets gathered across the company. And what the platform offers them. Platform produces and offers ready, customized, compliant, self-sufficient environments. So it's very easy for the teams to be onboarded. It's very simple for the teams to start working with those environments. They have all the tools. They have Databricks, data pipelines, pre-configured access to different data sources. They also have pre-configured security, and everything is done in a way that is compliant with corporate regulations and easy for us to provision and maintain. And this is very important because, as you will see later, this platform lives in a very complex and very rigid ecosystem. And there are other components of this ecosystem that we are reliant on, and this is both a design constraint for the platform, but also strength of the ecosystem, because those other platforms and other elements of the ecosystem abstract some things which we don't need to worry about and offer them to us as a service. So I will explain later, and please don't be scared. There will be a lot of diagrams here, but we'll try to guide you through them with the story. But we also wanted to have this session as a more technical session. That's why the diagrams and the drawings. Not everything is handled by the platform. Things like, for example, integrations. We have a middleware platform, which is a dedicated platform which produces integrations. It has different technologies under the hood. It has a lot of control monitoring and provisioning mechanisms built into it. And basically, it allows us, for example, to connect to Kafka streams and, for example, order some file transfers. And the platform takes care of everything, of arranging the network connectivity underneath, arranging the schedule for this, responding and resolving errors and recovering from those errors. We have monitoring, for example. On our platform, we don't do a lot of monitoring because we have a service for that. There's a separate dedicated platform with a separate dedicated team that handles monitoring and provides it as a service for us. And that monitoring platform is also hooked into all sorts of different auditor teams, reports, and so on. So this also is a service that we make use of. Right. And also the last but not least, the central services and business processes. For example, we don't have our ticketing system because there is one already. And we are actually connected to something which is well established in Lufthansa. This also kind of is a service to us. Identity and access. This is something which is also handled by some other teams, and adding people, adding access is governed by a certain regulatory process within the company, with approvers, with certain gates that need to be passed, but we don't care about it. That's why it's very important to think about the platform as part of a much bigger ecosystem with a lot of interconnections. But let's go into the One Data platform itself. So this environment, those environments that we produce for the data delivery teams, for the analysts, data scientists, and so on, we call them OTP spaces. And they are bubbles of ready-made, in a way, landing zones, but this is much more. They are already integrated into a large number of corporate elements of corporate IT infrastructure, different systems, different mechanisms and processes. And each of those spaces is a set of components which allow most of the data analytics, data processing, data engineering jobs. So the core elements is a lakehouse, plus data pipelines, plus Databricks and machine learning workspaces. The lakehouse is composed of storage and data factory. And all of those elements are provisioned automatically as part of the space provisioning process, pre-configured, and already hooked up with all the access, permissions, groups, and monitoring, everything that is needed and mandated by companies' policies. So there are, as you see, individual spaces, which are individual and they are used by the team which ordered them, but also the platform contains some shared resources, which spaces use collectively within, let's say, logical environments, not physical ones. We don't have Databricks workspaces as separate physical Azure components, but we have them shared with a logical separation between the teams. So there is a lot of other supporting mechanisms here, which are provided to the team which orders a space. That would be, for example, some Azure DevOps pipelines, which take care of things like building and publishing ADW pipelines. So they are all Git driven. All the ADFs are connected to Git by default. This is built as part of the provisioning. And also we provide and build as part of the provisioning the pipelines which to publish, which to build, which to checks, and so on. So you don't actually click publish on the data factory, which is a bad practice, but it's something which is already connected and built. The teams just operate on Git, and it's triggered by Git operations by merging, for example. Right, and of course, part of the shared infrastructure are the compute clusters behind Databricks, behind machine learning workspaces. So looking into the storage and what is provided out of the box as well for our teams, well, you can recognize classic medallion here, more or less. So classic medallion tiers, raw, standardized, curated, trusted. So this kind of represents bronze, silver, gold. We have a little bit flavored and opinionated to suit better the way the teams work and the way data is handled in Lufthansa. So raw, this is just a raw reservoir of input data. Then the data is kept in native formats for the sources. Standardized, this is basic standardization. So transforming to common file format, for example, which is one of the key processes there. Curated, this includes some data quality checks, but still important to note that this is not still with any business logic. And then transformation to trusted layer, which also can contain business logic, some consolidation, some additional measures which are created as this is being transitioned, and the output. So we have different ways of sharing this data, because this can be considered a data product, right? So this can either be exported somewhere, and we have various ways of various integration scenarios. For example, the one integration platform I mentioned already. We can actually ask the one integration platform to provide an integration pipeline for us and take this data product and deliver it somewhere, to some SharePoint, to some database somewhere in completely different place in the company. That's of course the reporting layer. So we have Tableau, we have Power BI, and we have Qlik. And we have also some different systems which are delivered via API, for example, and so on. This also is usually handled by the one integration platform. So Maciej, maybe take over now.
Okay, so let's just talk about the spaces. So how do we provision them? And one of the previous slides that you saw is there was a count of the resources. So one space is basically around 100 resources, Azure resources. So in order to manage that, you need to have some kind of a tools, and we chose actually Terraform, which was already mentioned here. And I want to actually take you through how we are organizing the Terraform. So having 100 resources and basically one tenant, I just counted the lines of code that provision one tenant is around 13,000 lines of Terraform code. It's not optimized because in Terraform you have lots of spaces, white spaces, so there's not actual 13,000 lines of code, but still it's a lot, right? And we have 75 tenants on 2 environments, dev and prod, so you can imagine how much code there is. It's lots of redundant code because of the way we are doing. So we have the basic modules, and think about the basic modules like your, for example, storage account. So we have an opinionated way of doing the storage account. So we cannot take a module from Terraform, Azure module. We need to make it a bit more compliant with the requirements coming from the CISO or the company security guys. Then this storage account, you can add a file system on a storage account. So storage account is just a container where you can add your file system, so your different folders. And this file system is yet another module. Then you can add a permission management. So this is really important. We are taking our data lake with all the permissions. So different teams have different permissions to different parts of the data lake. So it's secured. And this whole module will just create something more complex, right? And right now, a storage account can be used as well, like in data lake component, as well as in machine learning workspace, or you can provision it as well to the Databricks. So these components then are reused and are used as a Lego block. So you have those small little pieces, you build something bigger, and then this something bigger, if you do add a data lake, and for example, Databricks environment just creates you this macro component, this capability, which is a lake house, right? So in this way, we are having a set of repos with basic components and then taking them individually and assembling them into something more complex. We can control the platform. And here, all those modules, being so granular, can be upgraded individually, right? So we have the source repo, we do our semantic versioning. So for example, you have the storage account version 1, 2, 3, whatever. And if there is a change, for example, we have the ADF, and the ADF, we want to manage the ADF with the manage VNet. We can just change one module, which will be propagated to all those complex modules, to the capabilities, and allow us to basically, with a single run of the pipelines, which there's a set of them, multiple pipelines, upgrade the platform. And we can actually manage, because of this, each and every space, each and every component separately. So this granularity is something that is provides an added layer of complexity, but it as well allows us to control the components and, for example, have one tenant running on an older version of the storage account, for example, because of some requirements coming from the business, and eventually be upgraded to the newest code that is desired and we want to run upon. So that's the basic idea, how you approach. And now Kuba will show you the engine, which is the core of the platform.
Yeah, so this is actually the fun part, how this is all created and provisioned. So we are all about Git repos. We are Git operated, and every part of the platform, so the infrastructure code, the configuration code, the integration code, is in a set of repos. And the process for building an ODP space, well, first of all, there is a set of processes and repos which builds the basic structure of the platform. So those shared components that I talked about, Databricks, networking, shared integration runtimes for ADF, self-hosted, things like that. But those bubbles, those analytic environments we provision for the teams, they are built via such a pipeline. So unfortunately, we don't have a laser pointer, so I'll try to show this. First step is the configuration. So in this configuration, we have a repo which holds the configuration for all of the spaces. And there are parameters such as, for example, does the space need a SQL database? If yes, then there's a flag there, and the code will actually adapt and orient itself to provision a database. Does the tenant need 3 environments? Maybe they only need test and prod. They can have test, prod, and integration, for example. This is also configured this way. There are some very specific parameters which pertain to especially tenants or spaces that are Lufthansa subsidiaries. And they are just very separate companies with their separate ITs, the separate policies, and so on. So there are specifics, but basically all the configuration is held in a repo. Now, if we want to create a new ODP space, we just create a branch, we create a new set of configuration items, and we create a pull request. So now this triggers a bunch of things. First of all, there's a set of artifacts being created. The Terraform code which creates this repo is assembled from, as Maciej mentioned, those building blocks. And also there are templates which are used to create the pipelines which build the repos. And all that, also, once that's created, once the Terraform code is assembled, then there's Terraform plan being run. And this plan is also part of the set of artifacts, which is kind of packaged and submitted for pull request review. So if now the team, there are multiple reviewers which make sure that this is actually correct, that nothing will be impacted, nothing will be destroyed. There are warnings, of course, if there's anything out of ordinary, like if suddenly Terraform wants to destroy a resource or something like that. But in general, this goes through a review process. And once the pull request is accepted, is approved, then it triggers a bunch of other things. So those pipelines which were created here, the ones that know how to run the code and create the tenant, are then executed. And there are other things which are also pipeline driven, but not terraformed, but they use Azure CLI and APIs. They are also run in parallel, and this creates the whole repo. The whole space. Now, you can see here this flow that I showed in the previous slide, but now this is like a bigger picture. So on the left-hand side here, we have those basic building blocks. The code for the whole creation is being assembled from those building blocks. And we have building blocks that create databases. We have building blocks that create ADFs. We have Terraform code, which makes sure that we follow a naming convention. We have the naming convention module, which produces names used by other modules, so that it's all even the naming convention is code controlled. And you see those creation pipelines, Terraform plan and a set of artifacts presented for the pull request, and the rest being provisioned. So what else is being provisioned apart from Terraform resources? Those ADF pipelines for build and publish. Repos, the ones that are given to the teams. So a repo for the ADF, a repo for Databricks. Also, integration. So first of all, all networking is mandated to be run via private connectivity. So there is a set of private endpoints deployed, and everything is connected to those private endpoints. There are different types of integration runtimes we use for ADF. So we have ones which are in our VNet run on virtual machines, the self-hosted integration runtimes. So we also kind of apply them to the ADF that we provision for the team, and it means that they can readily use it. Identities, so for example, if a group of users is configured to be the access group in an ODP space, then this group is also correctly applied to Databricks so that users in this group can also have certain permissions in Databricks, in Purview, in AML, and so on. So all this is run by pipelines and triggered by certain gate operations. But not only that, this is run on demand. When we have a request to create a new space, then this happens. But also, this is triggered by itself on a schedule just to prevent configuration drift. So once per day, this is once or twice, depends on the case. This is run, and if, for example, somebody gets creative with some RBAC, then this gets reverted back to the approved configuration. So usually that, of course, doesn't happen, but just in case we want to prevent anything unauthorized, we want to prevent something accidental, this is always controlled that it doesn't drift. So you see that it all kind of fits into the pipeline that I showed in the previous slide, but also there's a much bigger context that not only physical elements are created, but also configuration for integrations, for access, and some auxiliary structures like repos for the team.
Okay, let's just talk about the self-service. So one of the paradigms of the platform is to give the possibility to user to actually provision it themselves, right? So for the time being, there's a request for the ODP space to be provisioned, and we as a team that manages that need to actually start running and prepare all the scripts and fill all the variables and start the engine. So in Lufthansa, there's this self-service portal which is actually backed up by the Backstage. So Backstage is like an automation developer portal where you can just go and you can start and order a predefined configuration or predefined set of the infrastructure and templates, some boilerplates for your development. It was devised mostly for the containerized applications, so mostly Java, C# or Golang, but we are trying to use that with ODP to enable the users or the customers, or our customers, to order the whole platform or specific components, because the platform is done in such a way that you don't have to get the whole space, you can just order a machine learning workspace. It's an opinionated way of working with machine learning in Lufthansa, so you can just order that. Or you can order a set of databases or your medallion. So we just hooked into this backstage, and part of our job was to actually enhance the backstage. So we took the code of the backstage, and backstage is working on something called actions. It's like yet another implementation of a pipeline, right? So you have your YAML engineering where you define what you want to do with the backstage, and then the backstage will just hook up into your engine. In our case, it's Azure DevOps still, CI/CD, and then do the magic, right? And then you have the portal integrated with basically your IAM system like Entra ID, and what it does as well. Whenever you provision basically some kind of infrastructure, you can create a service catalog. So basically service catalog is just an entity model that can draw you the environment that each customer has. So if you ordered, for example, a ML workspace, you see that this and this particular business unit owns the ML workspace, they owns some kind of an application, and this is in a Lufthansa thought as a map for knowing what infrastructure, especially in the cloud, each and every team is owning. So this is yet another basically example what the platform team will do. So we are not only doing the DevOps stuff, it's as well a lot of coding, and those self-service platforms are the future. So self-service portals are the future, and probably in the near future maybe we will go in this direction to enable the end user, you as a user, as a data engineer that wants to do some kind of data engineering or some kind of a machine learning, just enable that, wait a couple of minutes, 1 hour, and just start working. This will as well enable you to just provision your code into production in matter of hours rather than days or weeks. So this was thought as a yet another step in the future. So we just thought that maybe we will talk about more about some components that are as well part of the platform, but those are not strictly infrastructure related. So right now, I'm not sure how it's in your companies, but in those enterprises, there's hype about Gen AI. Everybody's doing LLMs. Everything must be LLM driven, and everybody is just provisioning and hundreds of applications that are based on LLMs. And this is something that together with Microsoft, so Lufthansa is one of the biggest account of the Microsoft. So I think we are in top 30. So we have lots of love coming from Microsoft. We devised this LLM. So basically think about this as a ready-to-use product. So basically it's a Git repo that will enable you to provision your LLM application. I'm not sure if anybody was yesterday on the AI workshop. Probably you saw the AI studio and this DAG, so prompt flow, so-called prompt flow, where you can build your application in this direct acyclic graph. So you have your nodes like ask the LLM, so OpenAI, ChatGPT about something, summarize me this, then you put your Python code to process the response, and then maybe ask one more time LLM, and then output a dashboard, something like this, right? So the prompt flow is a just framework developed by Microsoft that enables you doing that, and it's really simple. It's like you can give it literally to somebody with no coding experience or little coding experience, and they will be able to create for you a LLM application in matter of days, let's say. So it's no code approach, maybe a little code approach towards developing the LLM. And we developed this quick template. So basically it's a repo that is hooked into the platform which you can deploy. So you clone the repo is cloned for you and is integrated with Azure Machine Learning. And then there comes 2 other initiatives which are really right now something that we are doing, but this will enable you to have your environment, local environment, to start developing. Then with just a couple of pipeline runs, you can promote your environment to our dev or to prod, right? And this is fairly automatized, and this is offered as a service. So you can imagine right now there's a need for like 500 such an application where everybody wants to have a chat GPT for absolutely everything, right? So basically this will enable the teams to build our own GPTs, little GPTs, or the teams, right? So this brings yet another problem. I'm not sure if anybody of you works with the Azure OpenAI. So there's a capacity issue. Microsoft is not able to actually fit all those graphic cards into data centers, right? So for example, if you want to have your OpenAI account in West Europe, it's not possible, right? They would need to fit a small nuclear plant near the data center to power all those graphic cards. So then you need to use different accounts in different regions, right? So for example, Sweden is one of the regions that is not saturated yet. However, if you have different regions, you have different FQDNs and different, there's a different problem that you cannot seamlessly connect to those regions. And other than that, one subscription can host around 20 accounts. The need is really big. The problem is that some teams are saturating the OpenAI accounts, the other are not saturating. So basically you can have like 300,000 tokens per minute or something like that, but nobody's using that. So there's an initiative as well working with Microsoft, and this is the approach that we are currently taking. So we took some open source code and we are integrating it with another platform. So we are using, we are devising a load balancing option for OpenAI. So we have different regions with all those capacity that will be available for all the users. And then we are trying to expose a single stable endpoint for all our LLM applications that the team can tackle, right? And we are using the OIP, so it's one integration platform. So think of that like enterprise gateway that is the only job is to provide the connectivity to some backend services in a Lufthansa world. And this is yet another, let's say, example of the development and what the platform is meant to be, right? So the platform will enable the users to use the OpenAI, and they won't care about the capacity. They shouldn't care about the capacity. They shouldn't care about all the complexity that comes behind, right? So all the networking, all the DNS, all the stuff. So they will get a stable endpoint, user, and password, and tada, it works, right? So we need to build it in such a way that is Azure OpenAI compliant, and this is what is currently being devised. So as you can see in this example, this is a load balancing solution. So we hooked it into as well our Elastic Observability, so OBS, so yet another platform responsible for doing the end-to-end observability of our components in Lufthansa environment, as well as we are doing the FinOps, right? So if you have a shared load balancing solution, you need to track which individual customer is using, right? So this is the upper case with the log analytics and the Power BI where we would do all the FinOps and magical things.
And actually, OpenAI becomes a capability of the platform that can be presented to the users without them caring at all about anything here that is quite complex technically, but for them it's completely abstracted. And this is in an approved, certified Lufthansa compliant way.
Yeah, so with OpenAI comes yet another, so it's like a vector databases for your RAG use cases. So this is not just an endpoint of OpenAI, but a set of capabilities of machine learning and the cognitive services that Microsoft offers. So underneath is just plethora of services that we integrate, and the users do not care, right? They start using, they don't care about the permission, anything. They get the endpoint and they are logged in automatically, and it's done in such a manner that all the access is monitored, is logged, and if this space is for you, nobody else, unless you give them permission, will be able to use that. So this is yet another technicality that that we are doing, and this is the inference endpoint. So whenever you build your LLM application, basically it's a container, it's a set of code that needs to run in the environment, right? And since this is a container, we'll run it on our AKS, or Kubernetes cluster. And why we are doing that, it's one of the requirements of the corporate. So we need to have those endpoints controlled in our environment, in our network bubble, as well. Right now, Microsoft is not able to give us access to certain components like APIs that are exposed in a Lufthansa internal network, right? So we can have the private endpoints in a new networking model of the AML workspace, but you won't be able to call, for example, APIs, and those APIs are needed for various reasons. If we have the models on a Lufthansa page that for example, enable you to get some recommendation, they need to have your data about your flights, about your past, etc., etc. So then we need to get this data at the inference, right? So this just required us to build something like this, what you see here on the Kubernetes, and this guy gets into more even complex set of development capabilities that the platform should provide. So we thought about using native Microsoft. So Microsoft pushed us to use the, for example, API, but it costs like $1,100 a year. This solution that we have here is just a couple of dollars basically. So it's just doing the intelligent load balancing and some kind of integration with our OIP gateway. I won't go into the details how it works. It's nothing extraordinary, but still required us to devise some Go code, some VASM plugins, and some token service which is written in Python and enables to cache various keys and tokens which are then associated with various ML workspace. This is a multi-tenant solution, so it not only serves one customer, but like I think we have around 40 ML workspaces for different teams within Lufthansa. So I think that concludes, and we have those 10 minutes for questions and answers. Yeah, I thought you would ask. We've been on your
Mm-hmm.
What level of access you grant to the users that will
Right.
do you have some kind of a sandbox in your whole architecture for a new functionality that is not covered in the modules? Let's say, as an example, airflow AD. Someone would like to play around with it. You have some playground and you say, okay, let's play around here before we implement the main module.
So I maybe misspoke a little bit. It's not that we also grant high access for modifications. We don't at all. I just kind of use it as a figure of speech in case the configuration drifts in any way. So it's not that we allow it. It's not a kind of function that, okay, we can provision it by Terraform, but you can also go into the portal and click stuff around. Definitely not. It's just a measure to always have a guarantee that there is zero configuration drift. And if there is, then our monitoring platform, which is run by a different team, and we also have this alerting system and messages and alerts which are kind of spread across the company. If such a thing happens, different events, they will let us know, hey, we detected a configuration drift here and here, originating from this and this action, and we get a concise report that we can actually chase down people who did this. But in general, no, it doesn't. It doesn't happen. It's
yeah,
yes.
There's one thing just to mention. As we spoke, we live in an environment, right? So there's an ecosystem, and basically we do not provision the hub and spoke and landing zone of Azure. And this is controlled by the Azure or cloud team, and they basically have their own right on the subscription. So somebody from this team can amend. They shouldn't, because it's right now we are just going into PM direction, but there is a possibility that somebody can amend it manually. So we want to make sure that all our infrastructure is compliant, so we are secure, and there's no some audit policies on security on our back. It's not good. Yeah.
And what was the second question? Environment, sandbox. In general, we don't. There's no sandbox per se. We have the non-production environment and production environment, which are kind of similarly controlled and similarly mandated. So it's not the dev environment is dev, yes, but it also has a similar set of policies and similar level of control as the production environment. So for example, if you have a storage account, you can't have SaaS or key-based access to the storage account on dev, but not on prod. It doesn't happen across the board. But we also have a method of safely provisioning sandbox, semi-provisioning kind of sandbox spaces. And you can have your own via a certain process in Git. We have like a number of steps that we can do as some other development teams that they can just create this bubble for themselves. And this bubble is also, this has all the benefits of the platform. So it is a fully functioning bubble, but you can do stuff and break it and doesn't. So as Maciej said, a lot of stuff is available in every kind of sandbox environment as well. For example, OpenAI. You just have the possibility to use OpenAI, even though there's a lot of complicated technical stuff behind the curtains just to allow it, as Maciej presented. But then you can experiment with other stuff and yeah. So we have a way of creating sandbox bubbles and not a full sandbox environment. Yes?
Number of business number of projects, number of people. Each of them can be the LLMs and other resources. So how do you handle this problem? That projects have their budget, they get to somehow get approvals, purchase orders, and all that crappy stuff that actually sometimes
That's a great question. We have FinOps, basically. So you might recall there's this pull request approval step before anything is provisioned. That's a human gate at the moment, because if somebody approaches us and says, hey, we need an OTP space, then we need to make sure that there's somebody willing to pay the bill for it. So we use various mechanisms, like we have tags, for example. Every resource has a tag, and there is a mapping of those tags into projects and business units, so we can track costs by tag, and there's a whole kind of layer. We didn't put it on the diagrams, but there is a pretty hefty internal sub-project that has reporting, has this cost control per department, per project, per resource group, stuff which is easy for us to then attribute to certain owners inside the company. And this is why we have certain gates where we need to make sure that there's actually somebody willing to pay the bill for it. And if, for example, we have this confirmation, then we say, okay, the process can continue, the resources can be created, and billing can start.
And there's a set of additional, for example, jobs that we have.
Sorry, this is
so we have those jobs built into FinOps that, for example, go through all our infrastructure. Right now, I'm not sure if I mentioned, we have like 8,000 resources. So it goes through all the resources, and those resources that must have some certain tags with cost center, for example, and we get a daily reporting if something is missing a tag or something has changed, right? So cost centers are changing. We have a separated like FinOps module or tagging module that enables you to, for example, change those tags almost instantly for all those resources that that particular space has, and that's something that we use pretty often. So for example, you can imagine you had one customer with this cost center, and then it changes, and we need to update like hundreds of resources. You cannot do that manually. You need to have an automation for that, and this is part of the platform. It's just more boring, but yeah, it is. And there's this automation that validates checks, and we have the reports. If something is missing, then we need to go and figure it out. So it cannot be everything as a code. Hopefully we'll get there eventually, but we have a pretty decent automation, and if something is missing, we are just adding it, right? So there's part of this job. So as you said, somebody needs to pay the bill. If they don't pay, it falls on us. So we just make sure that we are not over the budget, and we reconcile the cost and send them to whoever is just supposed to pay for that.
And also our friends from the monitoring platform check the resources if there are any untagged ones. For example, if there is something which is provisioned and is not tagged properly according to the standards that can allow us to attribute the cost to a certain unit, then they generate alerts and they notify us, and if that happens, then we kind of correct everything. This sometimes happens when new functionalities are produced and maybe some omission is made, but basically this is checked as well. So the monitoring platform offers us this tool, this service, and tracks if we are properly tagging and cost controlling all our resources.
Yeah, exactly. For example, this is what I showed you with the load balancer. So this is like a key feature that you need to offer in the LLM world. And the problem there is you pay as you go, and basically the price is token based, right? And the even more challenging thing is that each token might cost differently. So the token from the ChatGPT is like 10 times more expensive than the token from the GPT-3 or the token from the ADA. So ADA is the embedding engine, right? And you have, and in different regions it might be that it costs differently, right? So you need to build this what I showed you on the log analytics. You need to build this feature into the platform that you can then reconcile the cost to the particular business unit. And right now there's so much hype that it just, the costs are skyrocketing, and this is yet another caveat of the job, right? That you need to have in this platform. So you need to think about this platform as a product, not just a DevOps on steroids. But really nice question. Thank you. Any other? No? If not, thank you.
Thank you so much. We really appreciate you being here with us at this hour. So thank you so much.